We've learned that if we have an even index, its result will be the absolute value of the radicand. If we had an odd index, the result will just be the radicand in that type of a fashion. So we can generalize this so that if n is even, I will have the absolute value of A. If, however, n is odd, then n square root of A to the nth will just equal A. Just the idea simply about what happens if it's even or if it's odd. That's all we're exploring right here, is what does the result look like, again, if n, the index, is even or odd. So for example, let's simplify the fourth root of x minus 3 to the fourth. How would we simplify that? Understand that it's an even index being raised with the radicand to that power. This is going to be equal to x minus 3, but the absolute value of x minus 3. We need to ensure that our result in here is positive. Let's look at the fifth root of 3x minus 2 to the fifth. It's an odd index, so its result in this case can just simply be 3x minus 2. Don't need an absolute value there because this value underneath can be negative. And lastly, the sixth root of negative 8 to the sixth. Look at our model here. If n is even, then the result would be the absolute value of that result. In this case, the value would be an 8.